As you can see, we are live now. Can you hear me? We are live. So we are live now. So if you are there, so please drop it in the comment section if you can hear me very well. Sorry for the delay. I'm trying to drop the link to the group and the message is not dropping. Alright, the message has dropped. I think by now most of you should have joined now. So I will not wait for anybody because I've wasted a lot of time. So I'm sorry for the delay. Immediately. I don't want to waste any time. So let's start. We're going to start now. Just want to ascertain if we are still connected. Okay, let me just try to. I want to ascertain whether we are connected. verify if you are hearing me. If you can hear me, please let me know. I'm trying to ascertain whether we are there. Okay. Can you hear me? I can see that I'm already. Sunday is already here. So please, let's speak up. Or you don't want us to do this live class again. So please, if we don't turn up tonight, I may not do it again. To just be doing the videos and that's all. Because I don't know, this time is when students are serious with their academics. Not this time that you still be begging you to come to live class. So do the needful. Can you hear me, please? Alright, Sylvia said you can hear me. I'm just trying to make sure I listen to but I couldn't listen to the video. I want to know the quality of the sound so that I'm trying to do something. The network is not so good. Okay, let's proceed, because if we say we should keep waiting, time is going. Time is not on our side. We have like 50 questions. What I just want to say, are you not hearing something like boom? That's what I want to ask. I'm charging my system, and when I'm charging it, it doesn't bring out quality sounds. That's what I'm trying to do. Alright, so let's start. I think we have waited enough for those of for the rates of the people. So let's start. So Heavenly Father, we thank you for today's class. Father, we say be thou exalted in Jesus' name. As we go into today's class, we pray that you take control and preeminence in Jesus' name. Thank you, Lord. Amen. So let's say amen in the comment section. So I want you guys, we are going to do these things together. So the first question is just that of which question type. So that one we don't need to answer question on that. So it depends on what the question type was on that year. Do you get? So that one is not our own concern. We want to do what is important. That's what is pertaining to us. That's what we want to do. And we are solving like 50 questions today. So we don't have time to waste. We don't have any words. We don't have any time to waste. So as fast as possible, going to the next question. So I want you guys to be active. When I ask you a question, you answer me as fast as possible in the comment section. Do you understand? So that's just so. All right. Let me just try to listen to the voice. This message. I'm trying to know how clear it is. And I don't know why it's not bringing out sound. It seems you guys can hear me very loudly, but notwithstanding, let us start. So we have done the first one. The first one I said doesn't mean, that's not our main thing. Now the second question, they said, what is the least possible error encountered when taking measurements with meter rule. So this one I've taught you in one of the videos that we did, so by now you should be able to answer the question. So what's the answer? Just drop it in the comment section and let me know. So it seems that most of you can already hear what I'm saying. So what's the answer? Drop it in the comment section. I'm waiting for you. I've told you guys that for meter rule, I've told you the least possible error for meter rule is 0.5 millimeter for that of a vernier caliper. So please make sure you bring out your notes and you are writing something down. The least possible error for vernier caliper is 0.05 millimeter, and the least possible error for micrometer screw gauge, I don't think I remember to teach you, so I'm teaching you like that though. So please, this one is 0.05 millimeter. There's something I still don't teach you. There's something I did not teach you, which is that's why I said this live class is very important. So for those of you that did not come, so if you miss it tonight, you would have missed a lot. And what is that thing? I didn't teach you that the spring balance is used to measure the weights. It's used to measure weights. So take note of that. Why the beam balance? The beam balance, or they can also call it chemical balance. Chemical balance is used to measure mass. So take note of that. And you should know how spring balance look. Now, they say what is the least possible error encountered when taking measurements with a meter rule. So please, I am meant to record this class. So that even if we are disconnected, you have access to the video. So meter rule, the least possible error is what? 0.005 millimeter. You can see vernier caliper is 0.05 millimeter. While micrometer screw gauge is measured is in what? 0.005 millimeter. Now UTME can be somehow tricky. Instead of saying millimeter, your answer can be in centimeter. Do you get what I'm saying? Your answer for a year can also be centimeter. So it just means you have to convert this millimeter to centimeter. And I have made a video for conversion in physics, so I don't need to buttress this again. Do you understand? So just convert it to centimeter and you are good to go. So our answer here is what is the least possible error in what encountered when taking measurement with a meter rule. So what's our answer there? So our answer is what? What's our answer? So that's what? 0.5 millimeter. So it's what? 0.5 millimeter. So if you check some of your series you are using, you pick something wrong. So that's why you need not to depend on it. So the answer is option C. So let's go to the next question. So the next question states thus, number 3. They said a quantities which required okay, now there's something I did not teach you here. That meter rule, you know that most of you know meter rule, that's ruler, right? Those meter rule in the laboratory that's normally 100 centimeter or 1 meter. So we use it to measure in the laboratory. What of vernier caliper? What do we use vernier caliper for? You can use it to measure something like a plank, something like please be writing them down. The radius of a bearing, of a ball bearing, you can still use it for that. Please, I will not write it down. Micrometer screw gauge. What can you use micrometers? Something that is very, very small, very, very tiny. Something like thickness of a cloth. That's all you use it for. But when you're talking of ball bearing, what do we use? Vernier caliper. When you're talking of something that's very, very tiny, so thickness of a wood now, that's very big. So that can be vernier caliper. Thickness of, now for example, all those your book. If you want to look for the thickness of one leaf of your book, what will you use? That is very thin. So that is micrometer screw gauge. So something that's very, very small, what do we use? We use what? Micrometer screw gauge. Do you understand? So we use what? Micrometer We use what? Micrometer screw gauge. Sorry, I'm trying to charge my phone. So we use micrometer screw gauge. I don't know why this video is not playing. So please, if you don't hear me again, let me know, because I don't even know how my sound is, and I must know how I'm sounding so that I will be able to. Alright, let's continue. I'm trying to check whether I'm connected. Alright. So the next question status, they said a quantities which require, so we have done this already, that's in scalar and vector quantity. So a quantity which requires magnitude and direction to be specified is what? Now, I told you that vector quantity is a quantity that requires both magnitude and dimension and direction, and that's what a vector quantity. Why a scalar quantity is a quantity that requires only magnitude but no direction, or has only magnitude but no direction. And I give you an example, a lot of them. So if you have not watched the video for scalar and vector quantity, go and watch them, because I will not have to be saying them again. Now let's look at this question. So I've given you a tip. So now for temperature, now is it a scalar or vector quantity? So I want you to drop it in the comment section. Please cooperate. If you are not cooperating, we may not be having this again. Temperature is a scalar quantity. There's no way that you cannot be saying SR. Why is it scalar quantity? So that's just how it is. So you have to just master them, because temperature, you cannot be saying 50 degrees Celsius towards the south. So you cannot say that. Temperature, it is only magnitude, it has no direction. But when we get to something like displacement it has distance, but that distance is in a specified direction. So distance now is a scalar quantity. Now displacement is a vector. That's why when we are saying difference between distance, we will say distance is a scalar quantity while displacement is a vector quantity. Now mass is a scalar quantity. Do you understand? So mass is a scalar quantity. Now what's our answer? They said we should look for something that is a vector quantity. So our answer is option C. So let's do the next question. If I'm making a mistake, let me know. Okay, you can see now they say another question on vector quantity. Now what's the answer? They said which, now even this, you should be able to do it. I told you anything energy, anything power, it is a scalar quantity. I've told you this. I've taught you this. Anything power, anything energy, anything work, anything kinetic energy, potential energy, anything power, work, all of them, they are what? Scalar quantity. So it means automatically the kinetic energy here is a what? It's a scalar quantity. What of electrical potential? It's also a what? It's also a scalar quantity. What of torque? Is a vector quantity. What of momentum? Momentum is a vector quantity. I actually created something like mass, distance, speed, electric potential that we just saw. All those work, energy, power. So all of them here, they are scalar. But weight, when we get to something like weight, force, impulse, momentum, something like that, they are what? Displacement, velocity, all of them, they are vector quantity. So try to know all the examples. You can see now they ask two questions on scalar and vector quantity. So please try to know their examples. They are very, very important. So torque, not only torque, even moment of a force is also a vector quantity. So our answer is what is vectored here? So that's 2 and 4. So that's our answer. So we go to the next question. They say which of the following do the wheels of a moving car undergo? Now let me show you. If your daddy is riding a car, you will see that the car is moving from point A to point B. Now if your dad's car is moving from point A to point B, I think I taught you this when I was teaching you motion, that when you move on a straight line, that is a translational motion. Now rotational motion is when, if you look at the tire of a car is going to be going straight up if you are moving on a straight line. But if you look at the tire of the car also, it is also going to be rotating, right? It will be rotating at the same time it will be moving forward. And I told you when something is moving forward, it is translational motion. Do you get what I'm saying? So another thing is that it is rotating, number one. Another thing is that it is what? It is going straight. So this type of question, it is actually not so, you cannot really say this is how it is going, because if other people come, they may say it is translational and rotational. If other people think, they will say it's oscillatory and rotational. But the right answer that should be is what? Rotational and translational. Some people can say it is oscillatory. Why? Because the tire can be vibrating, but it's not really, we cannot call it oscillatory really. So the answer is translational, because the tire is moving from one point to another, it's going on a straight line. Why the tire? The wheel of the tire, right, is the wheel, right? It's going to be rotating, right? So that's rotational motion. Do you get? So that's why we now say the answer is what? The wheels of a car, they undergo translational motion and rotational motion. So the next question we are looking for is, they said from the diagram below, that is, I'm going to show you the diagram now. They said we should look for the one that is zero acceleration. So now look at this point now. If they say something is acceleration, if this is a velocity diagram, right, this is the acceleration. So this acceleration is a what? It's called the acceleration. But if it is coming down like this, we call it what? Deceleration. Or we call it retardation. Now they may now ask you which one is a negative acceleration. This one also is, you can also call it negative acceleration. Why this is positive acceleration? You can see that acceleration normally it goes up in a straight line. It doesn't move like this. So it means when acceleration is like this, if your line is like this, at this region the acceleration is going to be zero. So that's why you see it now. You can see now the acceleration here is of a linear form. Do you see now? But when it gets to this place, it does not move up. So it means the acceleration here is zero. Do you get what I'm saying? Acceleration is known for moving up. So it means this one, it will not be zero. This one will be retardation. If they ask us what is retardation, this point PQ will be retardation or deceleration. This point PS will be retardation, but it will be acceleration rather. This point MN will be acceleration, but this point NS, acceleration is not occurring in this point. So this point, now this point, it is what? Zero acceleration. Now they may not ask you another question, then that what happened when we have zero acceleration? What actually happened is that the velocity is constant. So do you see now the velocity here will be 30. If you look at it, maybe the velocity here is 0, right? When it gets here, it becomes 30. When it gets here, maybe it becomes like 50. So you can see that the velocity changes here. It changes from 30 to 50. So that's why we are able to have acceleration. And that's why I told you that acceleration is the change in velocity to time. So it means here the acceleration is 30 here on n. When it gets to s, the acceleration is still 30. Do you get what I'm saying? So that's why we said now this is it. Look at it. You know acceleration is what? V minus u over t. I need to be practical. Look at it now. The acceleration, the initial acceleration here will be on this point n, it will be 30, right? That will be your u. Now your final velocity will now be at this point s. If you look at it, it is still 30. Do you get? It is still 30. So look at it now. It should not be 30 minus 30 over, even at some it not give us time, so let us say it is t. It should not be equal to 30 minus 30, 0 divided by t. 0 divided by t, what is that? 0. So that's why we said at this point ns we have what? 0 acceleration. So you can see that this thing is not so challenging. So look at this now. So this is a question of motion. they said a car accelerates uniformly from rest at 3 meters per second squared. This is the acceleration, 3 meters per second squared. They said the velocity, okay, it accelerates from rest. If something accelerates from rest, your initial velocity will be 0 meters per second. Do you get? They now say we should find the velocity. So it means the velocity they're now asking us is what is the final velocity. They now say they give us distance of 24 meters. So what are we looking for? We are looking for the final velocity. I told you whenever you are doing question of motion, the first thing you should do is that you should write all the 3 equations of motion. And what are they? S is equals to ut plus half at squared. That's the first one. The second one is a v is equals to u plus at. What is the third one? The third one is a v squared is equals to u squared plus 2as. Are you guys seeing my writing, or should I try to make it bigger? Can you see now? So this is 2as. Now look at the parameters you have here. Which equation do you think will go for them? So the answer is this one. So this is the one that have everything, because if you look at this one, you will need time. Here also we need time, and they did not give us anything like time. So you will use something that you can use. So let's use it. So we have v squared. We are looking for v squared. So v squared will now be, what's our u? 0 squared plus 2 times, what's our a? 3. What's our s? 24. So we now have v squared is equals to 0 plus 2 times 3, 6. 6 times 24. Let me try to bring out my calculator. Times 24, that's 144. That's what 144. So at the end of the day, we are going to be having v squared is equals to 144. So let's find the square root of both sides. So v will now be 12 meters per second. So that's our final velocity. So that's what they're asking us to find. You can see, if you are a big person, you firstly go and choose 144. You can see they will still put your answer there. That's UTME for you. So you have to be very patient. Don't be under pressure. So the answer is option A. Don't go and be rushing. So the question here is they're asking us to find the escape velocity. Now, and I think I've taught you this. If I've not taught you this, it means this will be a place for you to learn it. So this will be a place for you to learn it. I'm still trying to check whether we're connected. Please be dropping comments. Let me be knowing that. Don't just be watching the video. Dropping comments every minute so that we can know. So now the second question says calculate this. The 8th questions. Number 8 is calculate the escape velocity of a satellite launched from the Earth's surface if the radius of the Earth is 6.4 times 10 raised to power 6 meter. Look at your answer. Your answer is in kilometer per second. So you can see this question is somehow different from what you actually know. But don't panic. I'm going to teach you how to do it. So what you just have to do is, what's the formula for escape velocity? That's the first thing you need to firstly ask yourself. That's the first thing you firstly need to ask yourself. What's the formula for escape velocity? So the formula for escape velocity is what? Is equals to v is equals to 2g r. Why r is the what? Is the radius of the Earth. Is the what? Is the radius of the Earth. What is g? G is the acceleration due to gravity. So what are we looking for already? So they have given us the radius of the Earth. What is that? They've given us that of 6.4 times 10 raised to power. So they did not give you g, but as a physics student, you already know that g is constant already. So it is 10 meters per second squared. So just input your parameters and you get your answer. So you even do this before I finish. So that will be 2 times 10 times 6.4 times 10 raised to the power 6. So what do we have now? So please quickly do it. So when at the end of the day you'll be having 11.3 times 10 raised to the power 3 meters per second. So how will you convert this? Now our goal is to convert meter per second into kilometer per second. So I've told you, whenever you want to convert meter to kilometer, what will you do? You will divide by 1000. So divide by 1000 means you will divide this by 1000. And what is 10 raised to the power 3? That is what? 1000. So automatically 10 raised to the power 3 cancel what? 1000. So what do we get now? 11.3 kilometer per second. So that's the answer. So you can see that this thing is not hard. So our answer is 11.3. So our answer is option D. So let's go to, so this one, they said a heart. Please, this square type of question is somehow tricky. So please try to know what I want to teach you. So this one is still on the gravity, all those gravitational thing, all those weight on Earth, weight on other planets, things like that. They said an object of weight. Now there's something you need to know. The mass, when I think I taught you this, even if I don't teach you, there's a difference between mass and weight. And what's that difference? Mass is a scalar quantity. Weight is a vector quantity. What's another difference between them? Now this is the key difference. The unit of mass is kilogram. The unit of weight is Newton. Now I want to do the main difference now. Mass is constant. That is, if your mass is 10 kilogram on Earth, your mass will be 10 kilogram on Mars. That is the planet mass. Or even in the moon, your mass will be what? 50. If your mass is 50 kilogram on Earth, if you go to Port Harcourt, your mass will be 50 kilogram. If you go to Benin, your mass will be 50 kilogram. But your weight, it will change. Because you need to know that weight is equals to mass times acceleration due to gravity. Now this acceleration due to gravity, they even ask in one way that why is it that it changes, it varies. So the reason why it varies is because of the polar orbit and the rotation of the Earth and things like that. So this G, you know that this is mass, this M is mass. So this G, it's in some places it may be 9.8, it may be 9.9, it may be 10. You can see some of the calculation we normally do, we'll be using 9.8, sometimes we use 10. So that's what we are saying. So the G is not constant, so it cannot. This is what make the weight not to be constant. So the weight, what, it varies. So it means if you go to the solar, maybe you go to Mars, if you go to Jupiter, your weights will be different. So that's what this question is now trying to tell us, that an object of weight. But if you look at this one, they said weight, but they gave us a unit of what? Kilogram. So it means this is telling us that they gave us mass. Please, at times they may use them in physics, they may use mass and weight in the same way, but actually I want you to know that they are different. So you can see even in the option now, they said the weight of the object on the planet, they now later say, you can see they are in Newton. So the unit of weight is Newton, but some of the times they may change it and go and be using what? I'm going to be using kilograms. So don't be confused. Now in this question they gave us G to be 10 meters per second squared. Now they now said an object of weight 8 kilogram on Earth. You can see now that's the weight on Earth. So was taken to a planet where the acceleration due to gravity is 1/3 of its value on Earth. Now how do you do something like that? What is weight? I told you weight is equals to mass times acceleration due to gravity, right? So your weight will now be equals to, what's the mass? They've given us 80. They now said, okay, don't let me use that mass, let's just say mass times. They now said the acceleration due to gravity in that place, let us say the acceleration due to gravity in that planet, let us say it is what? GP, like that, right? So weight is equals to mass times acceleration due to gravity in that planet, that's GP, right? Now they now say this acceleration due to gravity in that planet is 1/3 of the value of the one on Earth, which they have given us already. So what is that? 1 over 3 of the one on Earth. So that would now be 1 over 3 times 10. So what is that? That's around 3.3. So what's our weight now? So our weight is now what? 80 times, what's our GP? That's 3.3. So what's our weight now? 80 times 3.3. So what's our answer? So just paste your calculator and we get our answer. Okay, alright, I think I've made a mistake somewhere, but I think this is how I should do it. But I think I've made a mistake somewhere. Oh, sorry, they made a mistake in the question. This is actually in Newton, so please, I'm sorry for that. They made a mistake in the question. It is actually 80 Newton. So I'm just looking at the way they did it in the first place. I was looking at that. It shouldn't be like that. So it is actually 80 kilogram. So 80 kilogram. So since the weight is already 80 kilogram, the next thing we are going to do is just say 80 times that will just be 80 times 80, so divided by 3. So that's just what we do. That is, it will just be because this 10 has already been used already, so just say 80 divided by 3. So what's the answer? So what's the answer? So our answer is 26.8. 26.6. So that's our answer. So that's what, 26.6. So what do you get? So that's our answer. Now you may be wondering, why did I not use 10? It's because our weight is already in Newton, right? So that means they have used the weight. You know that weight is normally mg/b, so they have already multiplied the mass by 10. So I don't need to use 10 again. Do you understand? So that's why I said, so we don't really need this value. So all you just have to do is just divide your weight of Earth over the 1/3 that they said, or if you multiply it by 1/3, that's just it. So that will be your weight in the planet. Do you understand? So that's how we get C. So let's quickly go to the next question. So we have a lot to do tonight. Now they said, what happens when 3 coplanar? They said what happened when 3 coplanar non-parallel forces are in equilibrium? Now there's something you need to know, that when we have in equilibrium, I taught you guys in equilibrium that, for those of you that are watching the videos I sent to you, for the link, I will send the link for you. Some of you that you should watch the video on Facebook, you will not listen to me. That's what one of his students, what a student did a year like that, and it's not really good. He has been very serious in the classes, but all of his studying, when we have live session, in which you will not show up. So when we are talking of non-coplanar force, this is how it looks like. So I have created a video for that. That's equilibrium of forces. Is on the group. Go and watch it on Telegram. So now, what are the characteristics of them? The characteristics that they are non-parallel. The next thing is that they meet at a point. can use it now. All of the line of forces, they meet at the point. They meet at the point. Do you understand? So they meet at the point. So you can use it now. So now they said when three non-coplanar or coplanar non-parallel, okay, they said coplanar non-parallel forces are in equilibrium. Number one, their line of action are parallel. Are they parallel like this? When they see something is parallel, they will not touch each other. Are they parallel like this? No. They are represented in magnitude alone. No. You can use it now. They have direction now, so it's not really on magnitude alone. So that's wrong. Option C, they are represented in direction alone. That's wrong. It's not even possible. The option D, you can see now their line of action, they meet at a common point. Can you see now? They all meet on a particular common point. So that's option D. So I've done this in equilibrium already. Go and watch the video. So they said an object of mass 20 kilogram is released from a height of 10 meter above the ground level. They now say we should find the kinetic energy of the object just before it hits the ground. Now they said the mass is what? 20 kilogram. They're giving us a height of 10 meter, right? Now the next thing we want to do is that we want to find the what? Kinetic energy. Now as you know this as a physics student, kinetic energy is what? Half mv squared. Potential energy is what? Mgh. If you look at all the parameters they are giving you, it can only work for that of P, that is potential energy. So here what you just have to do here is just say that kinetic energy when an object is still on motion, that is, for example, if you throw a stone downwards, you have a stone now from the top, maybe you are on a second story building and you now to throw the stone downwards, the stone is going to have potential energy before it moves. When it gets here, it's also going to have potential energy, but when it is on motion, it's going to have kinetic energy. There will be conversion from potential energy to kinetic energy. So because of that, you can now say the kinetic energy is equals to the what? To the potential energy. So in lieu of that, what's the formula for potential energy? Just use it like that. It will not be mgh. What's our mass? 20. Now, acceleration due to gravity, all of you know that it's a constant, though they may not give you a time, but just know it's already that it's 10. So just say it is 10. What's your height? That is 10. So what's our final answer like that? That is 2000 joule. So that's our answer. So our answer is option C. You can see that this thing is not hard. Just get the logic. They now say the energy in the nucleus of an atom produces heat, which can be used to generate what? Now this question is actually a confusing question because a lot of people can come out with a lot of things. That energy produced in the nucleus of an atom, it can actually be used in to turn the blades of a turbine. That is, you can use the energy in the nucleus, you can use it to make some fan, some turbine, some blade to move, and that will create what we call what? Kinetic energy. At the same time, when the rotation of the turbine the rotation of those turbine is also going to result in what? Electrical power. So it means the energy in the nucleus of an atom can produce both kinetic energy and electrical energy. But actually, our answer here is actually going to be, we just have to follow them, though the question is somehow confusing, but our answer here is what? So our answer here is actually mechanical energy. So our answer is what? Mechanical energy. Although the question is somehow confusing, but the answer is mechanical energy. That's the answer they chose. Not really. So you can say it's electrical, you can say it's, but let's just choose what they think is the right answer. So let's continue with the class. So hold on for me. I want you guys to drop some comment section, some comments. I want to know if you are still connected. that are available. Your comments are not really encouraging. You are not, since the time we started. This is something I normally tell you guys to be very careful about. When I tell you to comment, you comment where necessary. Okay. The number 14, a machine whose efficiency is what? 75%. They said it's used to lift a load of, so your load is what? 1000 Newton. They said we should calculate the effort. So your effort is unknown. They now said the velocity ratio is what? Is 4. And I told you that efficiency is a mechanical advantage over the velocity ratio times 100%. If you still remember. So if you want to know more about machine, go and watch the video for machine. So mechanical advantage, I told you the formula for mechanical advantage is load over efforts. Right? So it means for us to know the efforts, we need to firstly know the what? The mechanical advantage. Now the velocity ratio, I told you it is the what? Distance moved by the effort over distance moved by the load. Though we don't need to find the velocity ratio here because we already know the velocity ratio to be 4. Right? So please drop your comments where necessary. So now the next one is now what? We are now looking for, so this is our efficiency, which is 75%. So let's substitute all the parameters. We are looking for mechanical advantage so that we can use the mechanical advantage to find our effort. So our efficiency is what? 75%, which is equals to mechanical advantage over velocity ratio. What's our velocity ratio? That is 4 times 100. So 4 in 100, that's 25. So we have 75 is equals to mechanical advantage times 25. So divide by 25 divided by 25. So what do we have? So our mechanical advantage now equals to 3. So that's our mechanical advantage. And mechanical advantage is what? Load over effort. So what's our load? Our load is 1000. And what's our effort? That's what we are looking for. So efforts will now be equals to 1000 over 3. So what do we have? 333.3 Newton. So that's our answer. have units. Neither do same thing with velocity ratio. What's the radius of the wheel? Look at it. They said the radii, that's the plural for radius, of the wheel and azu are 800 millimeter and 200 millimeter respectively. So respectively means radius of the wheel is 800, azu is what, 200 millimeter. So since both of them they have the same units, you don't need to convert it. You just say we have 800 millimeter over 200 second one now is, now most of you, when you wake up early in the morning, you're going to see some, if you go to the grass, you see some droplet of water. Now what do we call this droplet of water? The small droplet of water that forms on the grass in early hours of the morning is, number one, A, owl, B, mist, C, dew, D, fog. I'm waiting for your answer. What's the answer? Is it the mist? Is it dew? Is it fog? So what's your answer? So the answer is dew. So fog, I think I've made a video on that. But if I've not made a video on that, so you should. I'm teaching you already now. So please make sure you know the definition for dew. They may ask it at times. Definition for mist. Definition for fog. Fog is some of the things. For example, if your dad is taking you in a car, you're going to notice that sometimes you're going to see you will not be able to see the ground. That is, you will not be able to see the atmosphere will be very cloudy. That is, you will not be able to see each other, right? When your dad is going in the car, or maybe even on bike. At times when you are going, some of you that goes to school early in the morning, you see that you are not seeing very well because of some fog. So we call it fog. Now dew is now droplets of water that you see early in the morning on leaves. Those are what? Dew. Sorry, it's not mist. I want to say dew. It's not mist. The answer is dew. So please, I'm sorry for that. The answer is dew. So, and we also have what we call the dew points. So that's also something you should know. You should know the definition. So dew is those things, that droplets of water you see early in the morning. So that's our answer. So you can drop the definition for dew points in the comment section. They say, what is the equivalent of 20 Kelvin in Celsius scale? Now you need to know this. When you want to convert degrees Celsius to Kelvin, you add 273. If you want to convert Kelvin to degrees Celsius, that's a Celsius scale, you will minus 273. Right? Now, how do you know what is the equivalent of 20 Kelvin in Celsius scale? I think there's actually a question, an error in this question. So there's minus in front of them, so there's an error in the question. So I'm sorry for that. So now, what is this now? So you want to convert Kelvin to Celsius scale. So how do you do that? Just say 20 Kelvin minus 273. So what do we have now? That's around that will be 20 minus 273. So that's what? Minus 253 degrees Celsius. Actually, this question, none of them is. This question is, there's no answer. No answer in this question. So no answer. So that's how we are supposed to do it, but there's no answer in this question. So now, Emmanuel, unfortunately, he said that he told me to solve this question on linear expansivity. He is not currently here in this live session, and he's the one that told me that I should teach you guys how to do calculation for linear expansivity, volume expansivity, area expansivity. And he himself is not here. Alright. The formula for linear expansivity is change in length, that is increase in length, over the original length times the change in temperature. That is, when we ask you to, this is the linear expansivity. This is represented by linear expansivity. That's linear expansivity, alright. We also have what we call the area expansivity. Area expansivity is represented by beta. So this one is area. So that one is change in area or increase in area over original area times change in temperature. Similarly, we still have what we call the volume expansivity, which one is represented by the gamma. The volume expansivity. So what's that? V2 minus V1 over V1 theta theta. So what do we have? So what's our V2? So our V2 is understand? They now said the linear expansivity is now what? 9 times 10 raised to the power minus 6 per Kelvin. They now say we should now find the volume of the bottle at this 50 degrees Celsius. And you know that this 50 degrees Celsius is what? It's our theta 2. So it means the volume that will be your theta 2 will now be what? Your V2. Do you get the logic of physics? Do you get? Now, they're giving us linear expansivity, not area and volume expansivity. And you know that for us to use the volume formula for volume, we have to convert the linear expansivity to volume expansivity, because type of question is one of the questions that students they miss a lot. When they ask you something that's the temperature, when they ask you, there's difference between specific capacity definition. There's difference between its capacity definition. If you watch my video on your Facebook, unfortunately Facebook told you this when I was teaching you introduction to wave. Or okay, Emmanuel asked me some question that he does that I did not teach you some place in physics, and that's why I told you guys that you should also always speak up. Some of my videos I've lost them. I've lost some of my videos, so I've tried to tell you guys that you should let me know the videos that I did not do. So it was the one that just drew my attention to this aspect. So now, I told you when I was teaching you the introduction that distance between two successive crests of a wave. This is the wave, right? I taught you in that introduction that this is the crest of a wave. This is the trough. Right? Sorry. So if this is your another crest, is another trough, right? Now you can see this is another crest. Now distance between this crest and this crest is wavelength. Distance between this trough and another trough is the wavelength. Now what is the question telling us? They said the distance between two successive crests of a wave is what? 15 centimeter. Divide it by, so let's convert it. So we have 0.15 meter. They now said, and the velocity is what? The velocity is 300 meter per second, right? They now say we should calculate the frequency. So this is a very simple question. We know the formula is V is equals to F lambda. So what's the frequency like that? So that's V over lambda. So what's our V? 300 over wavelength. So that's 0.15. So just do your answer and you'll get your answer. So let me bring out my calculator and just do it. 300 divided by 0.15. So that's 2000. So 2000 is the same thing as 2 times 10 raised to the power 3. So we have 2000 hertz. So that's the same thing as what? 2 times 10 raised to the power 3. So that's our option C. So let's go to the next aspect. Okay, hold on. Number 17 is D. So that's why I'm trying to check the comment section. I'm trying to, where did I even put my, can you guys hear me please? Let me know. And we have So the answer is Q. So please be very careful with all those questions. Now this is a question on echo, and I've taught you guys echo already, and I've given you a formula for echo. Whenever you have questions on echo, I give you a formula. The formula is, please, if you cannot hear me, let me know. The formula is 2x over t. What's your s? That's your distance. What's your t? That's your time. While your v is your speed or velocity. What are they asking us to find here? They ask us to find the distance. They said a boy receives the echo of his clap reflected by a nearby hill, which is what? 0.8 seconds later. That's your time. They now said how far is he from the hill? So that's your distance. Now, and you know that even I think technology give us the velocity of sand in here. But as a physics student, you need to know that the velocity of sand in the air the speed of sand in here is part of the things they should give you. Some of the time JAMB may intentionally not give you, so you have to know them offhand. The speed of sand in here is 340 meters per second. So it means we have gotten our v, we have gotten our t. What are we looking for? The distance. So that's 340 is equals to 2x over what's our time? 0.8. So we now have 340 times 0.8 is equals to 2x. So t will now be equals to 170. Okay, sorry, we divide by 2. That is a 170 times 0.8. So Sunday that you told me that number 70 is d. Have you tried to correct yourself? Why will that one will be t? Something that is the breaking point. We are talking of elastic limits. You were saying the answer will be t. How will t be the answer for elastic limits? So go and watch the video of elasticity. That's why you don't maybe that's why you don't understand what I did there. So go and watch the video for elasticity. Do you understand? So go and watch it. It seems you don't know how it works. On the graphs, we have the elastic limits, we have the maximum load, we have the yield points, we have the breaking points is where those lines break. So that's the breaking point. That's when it's the wire will break. So what will breaking points? They are even far from each other. They can never be each other. Elastic limit. How is elastic limit pertaining to breaking points? So away from that, so we are done with this. So we have 170 times 0.8. I bring my calculator. So we have 136. So that's our final answer. So let's take our answer. So I can see our answer is already here already. So that's 136. So look at this diagram now. This is like a closed pipe. So if those of you that don't watch the video for closed pipe, go and watch it too. I will not explain vividly again because I've taught you. So I taught you that if this is the closed pipe, right, this region, this is lambda over 4. This place is also what? Lambda over 4. You divide it again. This will be lambda over 4. Now, this is the in closed pipe. I told you that there's nothing like 2F knots. There's nothing like 4F knots. Now they ask it in one UTME that in closed pipe, what do we normally have? We have odd harmonics. What did I call it? We have what? Odd harmonics. We need that what you can have in closed pipe is F knots, 3F knots, 5F knots, 7F knots, and so on and so forth. What I'm saying, what is F naught? That's your fundamental frequency. So it means this one is if you look at this now, how many lambda over 4 do we have? That is 3. So it means we are under 3F knots. Do you understand? So this one is the entire length. So it means what are you doing now? You equate this entire length into what is lambda over 4. So it will now be lambda over 4 plus lambda over 4 plus lambda over 4. So what do we have? We have 3 lambda So look at this now. They said an object is placed 10 meters from a pinhole camera. So that's your what? Object distance. So object distance, I told you when I was teaching you all those mirror. So for those of you that you are skipping videos, you can see that you are missing a lot. So it is 10 meter. It now said from a pinhole camera of length 25 centimeters. So it means that image, that pinhole camera will give you an image of what? Of 25 centimeters. So that will be my image distance. And that is what? 25 centimeters. You can see it is centimeter. This one is in meter. So let's convert this to a centimeter. That will be 10 times 100. That's what? 1000 centimeter. Now, object distance is represented by U. Image distance is represented by V. Now, what are we doing now? They said here that the pinhole camera is of length 25 centimeters. It means when the object is being viewed by the pinhole camera, the distance the image is going to form is 25 centimeters. That's why I said the image distance is what? 25 centimeters. It's not as if I'm doing one trick. Do you understand? So our magnification is now equals to what? Image You guys did not tell me that this thing is doing boom 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 boom. And I try to ask you guys, please try to let me know when something is not doing very well. The video was saying boom since morning. I did not say anything. Try to speak up. I don't like the way the video was doing. It was when I checked it now, I noticed that it was doing boom 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 boom. Okay, yeah, you said it is D. Oh, sorry, I made a mistake. It's actually pain me. Should have tell me. So sorry, the answer is option D rather. Thank you for the correction. The answer is number D. So I'm sorry for that. So I'm trying to listen to myself. It seems that it remains only Sunday. And the rest were saying I should go with the class and did not show up. No worry. Don't worry. It's not your fault. I'm the one that have the time. I think with this, I'm not sure we are going to have another live session again. You guys are not really encouraging me. So let's do like this. So we have, if the focal length of a concave mirror, focal length is represented by F. So that's 2 centimeter. They now said if an object is placed 80 centimeter from it, so this one is object distance. So that is what U. That is 8 centimeter. They now said the image is at what? So the image is at what? So that's what V. That's the image distance. Do you understand? Let me check the question whether it's right or wrong, because this question is somehow vague. Please, there is a mistake in this question again. All these options is in centimeter. So please, the focal length, so this is what we are looking for, and you know that the formula for that is 1 over focal length is 1 over V plus 1 over U, right? So our focal length is already 2 centimeter. So our object distance is already 8 centimeter. So we are looking for V. So if you want to understand better, go and watch the video I made for. So we have 1 over V is equals to 1 over 2 minus 1 over 8. So thank you, Sunday, for that correction, because it would have pained me if you do not tell me. And also next time, when you, the reason why the video was sounding like that was because I'm charging my system, and when I'm charging it like that, that's how it normally do. So I was trying to, when we started the class, I was trying to ask question that how is the video doing? Is it not doing boom? I don't even know how do you guys enjoy the class, because the boom will not even allow you to hear what I'm saying. I was trying to tell you guys, try to tell me. You did not say anything. It means this video itself, it has like destroyed the video. How is the video be presentable? Please guys, try to talk when something is not working. Let me know so that I can quickly work on it. I was so shocked when I heard the sound. The sound was not really encouraging. So look at this now. So LCM, so 2 in 8 we have 4. 4 times 1, that's 4. 8 in 8. Okay, so 8 in 8 we have 1. So 1 times 1, so at the end of the day we are having 3 over 8. So 1 over V will now be equals to 3 over 8. So let's cross multiply. So we have 3V is equals to 8. So what's our V now? That is 8 over 3. So what's our final answer? So what's 8 over 3? So let me bring out my calculator. 8 over 3. So what do we have? We have 2.6. So that's our answer. I think that should be around 2.67. So at the end of the day, we are going to be having a 2.7. So our answer will be 2.7. So centimeter. So our answer is what? Option A. So that's our answer. So let's go to the next one. Now, in a compound microscope, the objective and the eyepiece focal length are what? What are they? If you know the answer, just tell me. In a compound microscope, the objective and the eyepiece focal lengths are A at infinity, B long, C short, D the same. So what's the answer? So the answer is that both of them is shorter. So it's short rather. Both of them is short. Both the focal length for objective and the eyepiece is short. But if they ask you which one is more short, that's where you have to know that the objective is actually shorter than the eyepiece. So the objective has a more shorter focal length than the what? Eyepiece. Though both of them have a short focal length, but the objective, that one is still what? Short. For example, both of them, they got they both failed, right? Maybe for eyepiece got E8 in mathematics, and objective lens now get what? F9. So both of them, they are failure, but when it comes to get to that of objective lens, that one is extra failure. So the focal length is what? Is more shorter in the objective. So let's go to number 32. Now, when a telescope is in normal use, the final image is at what? When you are using a telescope what do we use telescopes for? That's the first question you need to ask yourself. Telescope is used in what? In viewing all those images in the planets. So it's a very long distance that you are using this telescope for, right? So telescope is going to be measuring something that is at infinity, right? Because this, you are on the surface of the earth and you are looking at structures that are very, very millions kilometers to you. So the final image, when a telescope is in normal use, the final image is at infinity. So that's our answer. So the final image is at infinity. So this is where I think electroscope. Did I teach you electroscope? So please let me know. But even if I don't teach you, this is a question on electroscope. So they said so we have what we call the gold leaf electroscope. It is used to know the type of charge a particular substance has. So it looks like this. I'll just sketch it. I don't remember the diagram again, but I will just try to sketch. So don't mind my diagram. This looks like this. So this is the leaf. I don't remember the diagram again. I'm just trying to sketch it too. So it looks like this. I think I tried. So this will be your leaf. This will be the earth. So you have a earth here. This will be the earth. So this will be your gold leaf. So this will be the metal plate. This is where you bring the charge, right? So this is where you be your charge. So I want to know whether we are connected again. So alright, so I can see we are still connected. So this place is your leaf. Now they now said when you bring a negative charge rod, this is it. If you bring a rod towards this gold leaf electroscope, so when you bring it near the cap, this is the cap of the electroscope. So they now said the cap has a what? Positive charges. Now there's something you need to know. When the cap has a negative charge, a positive charge in the cap, at the gold leaf there will be negative, and vice versa. So if there is negative on this place, the gold leaf will be negative here. Now the gold leaf electroscope is going to like diverge. You can see that they are not touching each other. These places are not touching each other because what, these negative charges, they are like charges, and according to the law of all those charges, that uh, like charges they repel. That is, you now, for example, you don't, if you are not a girl, you won't like your friend the way you like a girl now, right? So that's like charges. For example, some of you, you have uh, maybe you are drinking Fanta. If it is your fellow friend that is a boy, you don't want to give the person, but if it's a girl now, you want to give the person. So that is like charges you repel. You don't like each other. But when it's a girl that asks you and you are a boy and you want it, you quickly give the girl. It means on like charges, you are on like charges. You are positive. You are negative, or the girl is positive. So you attract each other, right? So the same thing with this negative. Now look at the plate, the leaf. They are not touching each other because this is negative, this is negative, so they will not be able to touch each other. So now you now bring a negative charge. So what's going to happen is that, because this is negative, right, when you bring it near the cap, this leaf is going to collapse, then it will diverge again. So that's what the answer would be. So it will collapse and it will diverge again. So let's go to the next question. They said, what's charged? I taught you this one too, on all those electric field. Please, if I don't make a video on electric field, please let me know. All these videos I had, I have them, but maybe I've lost them. So that's what I'm trying to tell you. Try to look for the videos in the group. This video should be under electric field. I think I've taught you. So I've taught you. They said, what charge is stored in a 0.1 farad capacitor? So what did they give us like that? That's capacitance of a capacitor. So that's 0.1 farad. So when the voltage of 10 volts, so that's our V, that's 10V, right? So which is supply is connected across it. So they ask us to find charge. What's the formula? What is charge? The charge is the Q. So Q is what? Is the charge. Now what's the formula for charge? Formula for charge is CV. So what's our C? 0.1. What's our V? That is 10. 0.1 times 10, that is 1 coulomb. So that's our quantity of charge. So our answer here is what? Option A. So we are done with that. The next thing we are looking for is, so we are done with that option, number 1. Now here they ask us to find the effective capacitor. I think I made a video for this on my YouTube channel, so you can go and check my YouTube channel. I made a lot of things there. They said, this is number 35. They said we should calculate the effective capacitance. So effective capacitance, they may use any other things like equivalent capacitance. They may use other words like total capacitance and so on and so forth, or average capacitance. Now how do we find this type of capacitance? Now there's something you need to know. When you want to find these connections, this is a parallel connection. Do you understand? So how do you treat a parallel connection when you are under capacitor? This is one capacitor, this one capacitor, this one capacitor, this one capacitor, this one capacitor. How do you treat it when you are under parallel? Now this is the law. When you're under parallel connection, you will add them together. That is, for parallel connection, the total capacitance is what? C1 plus C2 plus C3. But when you're under series, it will not be 1 over CT. You know, when we are under resistance, if it is parallel, you'll be saying 1 over RT over 1 over R1. But this is different in terms of a capacitor. Do you understand? So it's different. So yeah, just add it together. So what do we have? That is 6 microfarad. So what do we have now? Now we have gotten 6 farad, Abby. So it means all this entire thing, we are going to now redraw the diagram. The diagram will now look like this. So this is 2 microfarad, this is 3 microfarad. So what do we have here? So this is 6 microfarad. Now I want to ask you the question, what is now this connection now? You can see they are joined in one end combined with another end. So this one is a series connection. So which formula are we going to use? Just use this. So our total will now be, which is our effective, will now be 1 over 2 plus 1 over 6 plus 1 over 3. By the way, I'm not the owner of this past question, so I got it online. So we get 1 over CT now is now equals to, so let's find the LCM. That's 6. So 3, we get 1, we get 2. So 1 over CT now will be equals to 3 plus 1, that is 4. So we have 6 over 6. So we now have 1 over CT will now be equals to 1. So our CT is equals to 1 microfarad. You can see you will find your answer when you do it. So when you don't find the answer, some of the time you don't know it in here. Now number 36. Number 36. What are they asking you to do here? The maximum power transfer occurs in a cell when the external resistance is what? The maximum power transfer occurs in a cell when the external resistance is what? So what's the answer here? I want you to tell me. So when do we have maximum power? So you need to know that a cell, the formula for all those things is, we have EMF is internal the current plus times the ST is the external resistance and this is the internal resistance. So what is power now? So power will now be I square R. The power can be IV, it can be anything, so it depends. Now what are they asking us now? They said the maximum power transfer is going to occur when the external resistance, this is the external resistance, so the answer is that when the external resistance is equals to the internal resistance. So that's when we're going to have maximum power transfer. So the answer is option B. So that's when we have what? Maximum power transfer. So when the external, this is the external resistance and this is the internal resistance. Do you understand? Now this question also I've taught you this also. They said if a matter wire, it has a length of what? 4 meters. So that's our length. They now say it has a cross-sectional area of 0.8. So that's your area. They now say it has a resistance of 60 ohms. They now say we should find the resistivity of the wire. So that's what we are looking for. So resistivity, what's the formula for resistivity? Resistivity is equals to the resistance over times area times over length. Or you say the resistance is what? Rho L over A. But you can rewrite it like this. So this is our resistivity. Please, I will not be able to be telling you everything one by one. This is resistivity. This is the resistance. This is the area. This is the length. So what are we looking for? So resistivity. Sunday, are you still there? Or you have do like your friends that have left? 60. They are the reason why I have not been having classes with you guys. They are not encouraging me. Okay, they've given us cross section area of what? 0.8. Now there's a problem here. The cross-sectional area here they give us is in millimeter squared, and your answer is in meter. You have to convert this millimeter squared to meter. Now this is where some candidates they make mistake. How do you convert millimeter to meter? What do? You will divide by what? 1000. So if you have 1 millimeter, okay, let me just say 1 meter make 1000 millimeter, right? Now so now square it now. So it means 1 meter squared. If you want to convert this millimeter squared into 1 meter squared, so it will now be 1 million. Do you see what I did here now? So it means for this one now, you now bring 0.8 here. So let's say this is our x. So you just make it subject of formula and just do it. So we now have 0.8 over. So that's 10 raised to power 6, Abby. You know this is 10 raised to power 6. So we now have what? We now have x. So that would now be, so 8 times 10 raised to power minus 1 over 10 raised to power 6. So let's bring this 10 raised to power 6 to the top. It will now be 8 times 10 raised to power minus 1 minus 6. So do we have? We have 8 times 10 raised to power minus 7 meter squared. Do you see now? So we have been able to convert the area into meter squared. So we just getting area, we have not gotten the resistivity. Sorry, this is not resistivity. What am I writing? This is not resistivity. This is resistivity. It's like this. So resistivity will now be equals to, what's my resistance? 60. What's my area that we just got now? We got 8 times 10 raised to power 7. So 10 raised to power minus 7. So what's my area? Length rather. What's my length? So my length is 4 meter. It's already in SI. So divide this by 4. We have 2. 60 times 2, that's 120. So 120 times 10 raised to power minus 7. So 120 is what? 1.2 times 10 raised to power 2. If you change this to standard form. So these things, they are just mathematics. So don't ask me how I do it. I've told you guys as go and join mathematics class that it's not only mathematics student that need it. So 1.2 times 10 raised to power minus 5. So that's our resistivity. So we are done with resistivity like that. So what's our answer? So they get 1.2 times 10 raised to power minus 6, and we will get 1.2 times 10. So let me try to check whether I think I've made a mistake somewhere. Maybe in the terms of looking for I think when I was converting the 0.8, I've made a mistake somewhere. Okay, you know what? Let me just express this. Instead of changing it to 8 times 10 raised to power minus 7, let me just leave it at s is equals to 0.8 times 10 raised to power minus 6. Let me just leave it like that. Let me now go and use it like that. So instead of doing an unnecessary mistake, so let me just say this one is Rome will now be 60 times 0.8 times 10 raised to power minus 6 over 4. So what do we have? We have 15 here. So let me try to bring out my calculator, and we have 15.8 times 10 raised to power minus 6. So I got the answer now. So I now get, oh, I still get different answer. 1.2 times 10 raised to power minus 5. That's what I still get. Or is it something that's okay? Let me try to. Oh, sorry. They make mistake in this question. This is 6. It's not 60. It's actually 6 ohms. So sorry for that. It's not 6. So it means here also is right. So so the answer is so we have 12 here. So we have 12 here. So we have 1 here. So we have 1 here. So at the end of the day, we'll be having 10 raised to power. So this is our answer. So you can see questions at times they may try to waste your time. So a circuit has a resistance of 200 ohms. We are getting too late on this thing, so I have to quickly rush. A circuit has a resistance of 200 ohms. The resistance of the circuit can be reduced to 120 ohms when, what is that? So when A, 300 ohms is connected to it in parallel, B, 800 ohms is connected to it in series, C, 150 ohms is connected to it in parallel, D, 240 ohms is resistor is connected to it in series. Firstly, by now you should be able to know that all these series should be wrong. Why? Because when you're under series for resistance, you're adding. So when we're saying we want to reduce 200 ohms to 120, so now they now said when you connect 80 now, so it means you'll be 200 times 80, that's 280. So it is not reducing. If you take this 240 again, 240 plus 200, that will be 440. So that is not increasing, it's not reducing. But let's just try that of the parallel that they gave us, option A and option C. So all we just have to do is we want to reduce what? 200 ohms, right? So it means if our first resistor here is 200 ohms, what's our goal? We want to get a total of 120 ohms, right? So the first one we want to test is, we want to do also options test. We want to test the option A. So what's our formula? 1 over total is equals to 1 over R1 plus 1 over R2. So 1 over R total now is 1 over 200 plus 1 over 300. So what is that? So the FCM should be CS100. So 3 plus 2. So 1 over R total now will now be equals to 5 over 600. So R total now will be equals to 600 over 5. So what's our answer? 120 ohms. So this is our total. So you can see that we've been able to get the 120. So it means our answer is option what? Option A. So that's our answer. So if you try that of 150, you will not be able to get the 120. I don't need to waste my time on that again. Let's go to number 39. A PHCN measured, now PHCN, these are the power distribution company, maybe to around 2015 2014, but when maybe around 2015 or 2016 they changed them to all those Ibadan electricity distribution company. We have a lot of them in Nigeria, like four companies like that they sold PHCN for. So PHCN is like those power distributing company. In fact, so this question is 2014, so PHCN is still in existence. So they are power holding company of Nigeria those time. They are the one in charge of electricity. They are the one that even distributed all those bills that we pay. So you know that they are NEPA before they become PHCN. After PHCN, they now change again. Now, how do they measure their electrical energy? The answer is kilowatts hour. If you have a chance to see a meter, so So you see this thing there. So kilowatt hour. Even if they bring the bill, if you're a person that you are good in observing, they normally they normally put this thing here, kilowatt hour. That's the answer. So kilowatt hour. So actually, there's a way you calculate. There's a calculation that you do, that you know how to calculate it, how they get the number of bill and terms of that. Now, what is the best method of demagnetizing a steel bar magnet? So we have different methods for demagnetizing a steel bar magnet, but here they want to be specific. They're asking you something specific. That is, what is the best method that you can use to demagnetize a particular magnet? So what do you think is the answer? The best method? Just try your luck. So you can demagnetize a steel bar magnet by hammering, by heating, by rough handling it, by solenoid method. But what is the best method? So the answer is solenoid process. And you, by now in magnet, if you are a person that, if you watch my video on magnetism, I think I touched the aspect. So the best method of demagnetizing a magnet is what? Using the solenoid process. So let me check whether we are still connected. So we have 10 more questions to go. And so it's not heating, though heating is part of the method for demagnetizing a steel bar, but the best method is solenoid process. Thank you for contributing, I really appreciate it. And Kelvin and Sunday, I really, you guys, you desire, though I may not have a gift for you, but I know God will reward you. Thank you for staying, because what will I be doing if I'm teaching myself alone? I really appreciate your tenacity. So now the magnitude of the angle of dip. Now this question, this thing, I think I've taught you, I should teach you guys under magnetism. There's something you need to know, that the angle of dip at the equator is what? Is 0. You need to know that. So if I ask you now, what's the angle at dip at around Jos, Plateau Jos? Plateau Jos is very near to the equator. So I think they ask it in one JAMB like that. I can still remember. They ask it that what is the angle of dip at the equator? So this 0. So the answer is 0. And I think they use Plateau Jos as example. So the angle of dip at what? At the equator is what? Is 0. So please, these are things that you are meant to know as a UTME candidate. So the angle of dip at the equator is what? Is 0 degrees Celsius. So let us continue. We are going to finish the question. Just that I'm not sure if this live session, it seems you guys don't like the live session, so maybe, I'm not sure if we are going to be doing it regularly. I was trying to do something like this on April, but my April is kind of tidy up, and you guys are not really encouraging at all. Only 2 of you is available, You're not encouraging me at all. So the angle of dip, which is also called angle of inclination. So if I ask you what's another name for angle of dip, so there are two. We have the all those another one. So the angle of dip at the equator is what, 0 degrees Celsius. Now look at this now. I think I made a video on this. Yes, I can remember. It's on YouTube, so you can want to watch it. So now what am I saying? And this thing I explained it when I was under magnetism, so I have explained it, so I don't need to talk much on it again. So what is the thing here? So it's on my YouTube video. I made a video on that. Look at this. If you see this one, the number of wire here is very small. The number of wire here is much, right? In this type of transformer, when the number of turns, this is the primary coil, this is the one that is input is the primary, the one that is output is your secondary. Now when the number of turns in the primary is greater than the number of turns in the secondary, you should know that the number of wire is in input is very small. Is less than the number of turns in the secondary. This type of transformer is a step up transformer. But when the number of wire here is very much, like something like this, so they may ask in any way, maybe you have something like this. So when you see now, the number of wire here is much, the number of wire here is small. So this type of one is right. So this one here is a step down transformer. Do you guys get what I'm saying? So this one is a step down transformer. So let's go. So our answer here is what, step up transformer. So this one is a step up. So the next thing we're asking us is, what do you think is going to happen? This one that I have wire, what do you think will happen to the electromotive force? That's the next question they're asking us. That is, what do you think will happen to the electromotive force since it is stepping up? Now I want to ask you, what is in stepping? I said it is a step up transformer. What is this transformer stepping up? It's actually stepping up the current, the electromotive force. So it means the electromotive force will increase, right? So that's what will be the answer. So the electromotive force in the secondary winding will be increasing. But if it is for a step down transformer, what you want to do is that you want to step the electromotive force, you want to step it down, right? So it means if it's a step down transformer, the electromotive force will be going down. So you can see that these things, they are application, right? They are just application. Just know them. And so we just know them and you are good to go. Now look at this type of reaction. They say what type of reaction is represented by the question this, and so which type of reaction is that? Let me try to write it out. So this is your energy, right? Now what are they asking us to find? They say what type of reaction is this? So what is your answer? Is it ionization energy in reaction? Is this fission? Is it fusion? Is this chain reaction? So what's your answer? So I made a video on that also, so you can check it on Please, all the video I'm telling you to watch, if you are not watching them, yeah, I will not say anything. Oh. So a fusion reaction, I told you when I was defining fusion, is the combination of lighter nuclei to form a heavier. You can see that these ones, they are lighter. They now form a what? A heavier nuclei with the emission of what? Energy. So the answer is fusion. That is, they fuse together. So the answer is fusion. They said when an atom undergoes a beta decay. Now, what do they mean by beta decay? Beta decay is that when an atom, for example, maybe this is the atom. If it is helium now, you know that helium, it has mass number of 4, atomic number of 2, or number of photon of 2. They say if it undergoes a beta decay means it's beta is emitted from it, right? So it means the new elements is formed is going to have what? You know that it must be balanced. So it means this one will be 3, this will be 4. So when you add it, 4 plus 0, you have 4, right? 3 minus 1, you have 2. Now what is the implication? You can see that the atomic number, you know that this is atomic number, it moves from 2 to 3. So it means when an atom undergoes beta decay, what is going to happen? The atomic number of the nucleus will increase by 1. So it increases by 1. That's the answer. Now, having been, the question says if it undergoes a alpha decay. Alpha decay means helium is the alpha particle. So don't let me use helium as example, because helium is still alpha. Is the alpha decay. So if I say element, okay, let me use oxygen. If it undergoes a alpha decay. Alpha decay means alpha particle is emitted. Alpha particle is represented by helium atom. So the new element forms its X, right? So what's going to, if you ask me, what's going to happen to the atomic number? So the atomic number will reduce by 2. What's going to happen to the mass number? The mass number will reduce by 4. That's what will be your answer. Do you get the logic? So you just have to balance it, so that when you add 12 plus 4, you have 16. 6 plus 2, you have 8. It's just balancing, simple thing. But what they ask us is actually beta decay. So I just use this one as an example. And don't forget, alpha particles is represented by what? By helium. Now the next question here is, they ask us, this is a question on electrolysis. I've taught you this also. There's a video for this also. I'll drop it on Telegram. Go and watch the video. Without much further ado, no further ado, they said calculate the mass. We have spent more than 2 hours 20 minutes. Calculate the mass of the copper deposited. Please let me check whether we are connected. So if you are still there, please let me know. You guys, you did very well. You did very well. I pray that you guys will succeed in this UTME in Jesus' name, because I'm very happy seeing students are very serious. I'm always very, very happy, because so calculate the mass of, you know that the formula for electrolysis, the Faraday first law of electrolysis, state that the mass of an element deposited, doing electrolysis is directly proportional to the quantity of charge, right? You remove the proportional sign, you have M is equals to, when you remove the proportional sign, you have Z. You know, Z is represented like K, just like the proportional sign of proportionality, right? So instead of having K, you have Z. So this Z, what do we call it? That's what we call electrochemical equivalence. And I told you when I think I said it in that video, that electrochemical equivalence is ECE. So if you look at the question that they've given you already, so you can see the ZZ. So this question is simple. They've given you the time already. Time is what? 2 hours. I'm going to tell you how to use it now. Now, I'm not done with this. What is Q? Q is equals to IT. So what do we now have now? M is equals to ZIT. What is my I? That's my current. What is my T? That's my time. What's my M? That's my mass. What's my Z? Electrochemical equivalent. So we are looking for mass, right? What's my current? They've given us 4 ampere. Now this time, you know that I need to convert to seconds. So that will be 2 times 3600. When you want to convert hours to seconds, you multiply by 3600. So time will now be, when you want to calculate minutes to seconds, you multiply by 60. When you're now going from hours to seconds, you multiply by 60 times 60. 60 seconds make 1 minute, 60 minutes make 1 hour. So it means you moved between 260. So it will now be 60 times 60. So that's 3600. So what's my time now? 7200 seconds. So what's my electrochemical equivalent? That's 3.3 times 10 to the power minus 7. What's my current? 4. What's my T? That's 7200. We have gotten it here. So what's my mass now? We now have 3.3 times 10 to the power minus 7 times. So let me bring out my calculator and let's just do it once and for all. So we have 3.3 times 10 to the power minus 7 times 4 times 7200. Oh, sorry, I've made a mistake. Oh my god. Times 4 times 7200. So what do we have? We have 9.5 times 10 to the power minus 3. So what's my answer? So 9.5 times 10 to the power minus 3. What's the unit for mass? That's kilogram. So without wasting much of our time, what do you see here? Option C. Let's go to number 47. I think I taught you this in one of the videos we did, that the color of some substance when you look at them in the discharge tubes. So one of those elements is this. They said, what is the color? So what is the color given by? They say, which gas produces a pink colored light in a discharge tube? So what's the answer for that? So what color is that? What color? I'm trying to. Okay. So which one gives us a pink color? So that's why you see that this live session was, you are able to learn a lot. So that's why I prefer live session at times, not just that I'm just dropping videos, and that's why I feel frustrated when some of you don't come around. It's something that you should be very delightful for. and that's why the paid class is different from the free class. I have to cancel the paid class, the free class, because of the paid class. So it is actually argon that gives us a pink color. So argon gives what? A pink. So it is the one that produces. So we have some element that they produce specific lights with in a distance tube. So argon gives us what? A pink or violet color. So that's it. So we also have other colors which I'm going to be listing now. So the other color is neon. So what is the color of neon? So all these things, they are noble gases. So what I'm just trying to emphasize here is that some noble gases there. So neon, it produces red. So mercury gives us what? It gives us blue or violet. So but the answer here is what? Is argon. You can see here is not even part of it. Look at it, they still has the same question again. That is, when you can see all the questions they're asking here is on atomic physics. About, you can see they ask like, you can see from about 44, they ask like up to, this is on basic electronics, this is also basic electronics. These questions, they ask like 4 questions, 5 questions on atomic physics. So you can see the question will come across different branches of physics. They have asked questions on mechanisms, electricity, and all of them. So look at this now. We are left with 3 more questions. You guys can go and sleep. So this is lead. We have the mass number of 210. We have a atomic number of 82. So what do we have now? You now say it decays to what? Please, this is how to do it whenever you have questions like this. It decays to what? To 20880. Please, Kelvin and Sunday, I hope you guys are writing something down. So please write something down. That habit of not jotting is not good though. Now look at this now. They said it decays to this. Now what do you notice now? The mass number reduced by 4. The atomic number what? Reduced by 2. So it means the element form the what? We have 4. Add it together. What do we have? What do we have? Now, how many alpha particle is this? You can see that this is alpha particle. I told you alpha particle is helium atom. Had it been we have something like X, and we have 0, and we have -1, it would have been beta particle. But if you look here, how many alpha particles? Just 1. So the answer is an alpha particle. So you can see how alpha decays, how they work. Now this is on basic electronics. So these questions is on what? Number 49 and 40 is on basic electronics. I will have video on that also. And please remind me, there are some videos I may not remember to drop. So please try to remind me and drop them. Go through the syllabus and the videos I'm here to drop. Just let me know. They said in a common emitter configuration, the output voltage is through the watts. In a common emitter configuration, the output voltage is through the watts. So this question is actually from basic electronics. The way I've said it before, I told you it is from what? Basic electronics. So we have a lot of things in basic electronics. So the output voltage is what? Is through what? So what's the answer? If you know it, just drop it in the comment section. I want to know. Oh yeah, what's the answer? In a common emitter configuration, the output voltage is through the what? So the answer is emitter. So it emits. So it's through the emitter that you have the output voltage. So go and watch the video for uh, basic electronics. So number 50, which of the graph in some of the things places you will see base, choosing them they can choose base, but emitter is the answer. Which of the graph below shows the characteristic of an IV transistor? So that's what we want to look at here. That is the graph that shows the IV transistor. And this is the last question for today, and after that you can go and sleep. So the answer here is what? The one that shows the IV transistor. So the answer is D. So that the answer is D. That's the answer. So you can now. So before we round up, hold on. So the answer here is what? Option D. So I've said that. But concerning this question, there's actually a lot of contradictions there. The answer is actually between base and emitter, but I think the answer is base. Let's go for that. So thank you for watching today's live sessions. Please, I really appreciate you guys for staying to the end. It really shows you are very very serious. Please, everything you have learned today, try to. This is how to develop yourself. You go through those things in your textbooks. If there is some things you don't know, you go to the textbook and you understand them. So please, I really appreciate uh your your endurance, everything. I really appreciate. Thank you for staying to the end, and I pray God bless you in Jesus' name. Amen. So this is the end of today's live session. So you can now disconnect. Bye.